From this presentation we will start our number system. First of all, we will see the different types of number systems that are available to us, and after that we will see the conversion part, that is the most important part of the number system, and most of the questions used to come from the conversion part. So number system, it can be broadly classified into two types. The first one is your weighted code, and the another one is your unweighted code. I will tell you what is this weighted code and unweighted code, but let me write down some examples of it. If you see the weighted code, then the examples are decimal number system that we use in our daily life, the binary, octal, hexadecimal, etc. Okay, if I write the example of unweighted code, then it is your XS3 code, your gray code, etc. So we have categorized our number system, or you can say the code, into two types. The first one is your weighted code, where there is a weight for the position. We will see how it is done. And the another one is your unweighted code. We have also written the examples of your weighted code, that are decimal, binary, octal, hexadecimal, and any other base number if you choose. And the unweighted code is your XS3 code and gray code. Okay, so now first let me define what is your base. Okay, generally if I say base, then we mean R. Your base is represented by R. This is because we also call base as radix. Okay, the base is also called as radix, and from this radix only, this R we use to represent the base. Okay, now for every number system there is a base specified, or you can say that the number system that we study in any context okay, is dependent upon the base. For example, if I say R is equal to 10, it means the base is equal to 10, and if the base is 10, it means there are 10 different numbers involved. Okay, there are 10 different numbers involved, and these numbers are from 0 to R minus 1. Okay, this thing is important, from 0 to R minus 1. So the 10 is your decimal system, we all know. The 10 is your decimal system, and if I find out the different numbers, then they are 0 to 10 minus 1, which is 0 to 9. So in decimal, from our beginning in our play school, or you can say from nursery or in KGs, the teacher always tell us that the numbers are from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And by the combination of the 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, we are having different numbers. For example, I am having 7, 3, 4, 2. In this you will see that there are numbers involved from 0 to 9 only. 7 is between 0 to 9, 3 is also, 4 is also, and 2 is also between 0 to 9. So by arranging them, we are having a particular quantity. This shows a quantity. 7,342. It can be anything. It can be money, it can be, water, liter in liters, it can be distance, it can be anything. So it shows a quantity, it shows quantity. Okay, so this is how, depending upon the base, we find the different numbers involved in that particular base. Now if I say that the base is equal to 2, this is our base, r is equal to 2. So this 2, if this 2 is the base, then we call it as the binary system. Okay, it is the binary system. Why it is the binary system, we will find out. Because if I move to find out the distinct numbers involved in this binary system, then it will be 0 to 2 minus 1. It is r minus 1. Here r is equal to 2. So it comes out to 0 to 1. So there are only two numbers involved, 0 and 1. And because there are two numbers involved, it is called as the binary. The binary is for your 2. Okay. So this is how we deal with the binary when we have to find out the number of digits involved. Not digits, we call it bits. Okay, I will tell you what is difference between bits and digits. A very slight difference. Now if someone asks me what happen if we are having base equal to 8, that is our base. So I am having 0 to 8 minus 1 digits, that is 0 to 7, from 0 to 7. So if I have to write any number in your system that is having the base equal to 8, the base equal to 8 means it is octal. Okay, so then the number should be something like 8761. In this, sorry, 8 will not come here because we are not having 8, so 8 will not come here. This is what I want to tell you, that it should be 7652. In this you will find the numbers from 0 to 7. There is no 8 and 9 involved because it is octal system. Similarly, if I give an example of a binary system, then it is 01101. In this only 0 and 1 will be there. There is no 2, no 3, no 4 because it is not involved in this number system. So this is how actually the number system works depending upon its base. After that we will see a little bit of intuition that will be helpful to us to understand how this number system actually works. We will take it as a decimal system. Let us suppose the number given to us is 7342. Now what actually this number written here represents? It is 7 thousands, 3 hundreds, 4 tens and 2 ones. Okay, it is actually the quantity that represents the summation of these things, the 7000 with 3 hundreds, with 4 tens, with 2 ones. So it should be something like this: 7000, 300, 4 tens and 2 ones. If I sum them up, then it should be 2437. Okay, the number is generally written in this form. The powers of 10 is not represented. The powers of 10 means it is equivalent to, if I write 7 multiplied by 10 to the power 3, because it can be written as 7 multiplied by 10 to the power 3 plus 3 multiplied by 10 to the power 2 plus 4 multiplied by 10 to the power 1 plus 2 multiplied by 10 to the power 0. So generally this powers of 10 are not written with the number. It can be determined, or it is understood with the position. Here the position of 7 tells us that the power of 10 is 10 to the power 3, because if I write 0, 1, 2, 3, then this 3 goes to the power of 10. Similarly, if I write the multiplier or the power of the 10, then it is equal to 10 to the power 2, and this one is 10 to the power 1, and this one is 10 to the power 0. And these things are not shown with the number, it is understood by its position. So this is a little bit that I wanted to tell you about how the numbers are being written, and this particular thing that I have told you here is going to help you understand the different number systems. We will use this concept to find out what happens in case of the different number system, and we will lay our stress on the other number systems that are binary, octal and hexadecimal only. Rest of the number system you can understand if you once got what is happening in this number systems. So I think this is all for this presentation. From the next presentation we will see a little bit of examples in your binary and the other number systems. Then we will move to a much important part, that is your conversion.